All right, today we're looking at inverse functions and how the derivatives of inverse functions relate to each other. So let's start with this situation right here. We have this function, we want to graph it and its inverse. This should be a pretty easy one to graph. We'll graph the function in blue. We have a point at 0, 0, 1, 1, 4, 2, 9, 3. There's our blue function. And then the inverse is what we get if we switch the x and y. So we have y equals x squared in that case. So we have 0, 0, 1, 1, 2, 4, and then 3, 9. We get this function, this function right here. Okay, so there's our two graphs. Now, what we want to look at is how the derivatives relate to each other. We already know how the points relate to each other. We know that the x and y are flipped. So the first point, or let's say this point, we'll do it in purple. This point on the blue graph is 4, 2. And this point on the red graph, this corresponding point is what we can call it, is 2, 4. So the x and y are flipped. But what happens to the slopes at those graphs? The curve should be about the same shape, but it's going in different directions. Well, if we look, we can find it ourselves. Let's take this point right here, because this is an easy one. The derivative of our original is 1 over 2 root x. The derivative of our inverse is 2x. If we plug in this point on the blue graph, that's 1 over 2. If we plug in that point on the red graph, the corresponding point, which is also at 1, we get 2. Okay, we might see a pattern there. Let's try our other point, the 2, 4, and 4, 2. On the blue graph, we'll plug in 4, so f prime of 4, and we get 1 over 4. The red graph, we'll plug in 2, dy over dx equals 4. That's another interesting relationship. And if you're not catching on, what happens is at these corresponding points, the derivatives are reciprocals. At the corresponding points, the derivatives are reciprocals. So to do this, to figure this out, we're going to actually create a chart on problems that involve the inverse. Okay? So let's say for this one, we want to find the inverse derivative for the function f at the given number a. So what we're going to do is we're going to create a chart. We're going to create a chart where along the top we have the points. So here's f of x, here's the inverse, and then we have the points along the top and the derivative along the bottom. So we want the inverse at a. So that means a is the x of our inverse. So this would be the inverse derivative at a is equal to there. So the a they gave us was 3 in this case. So we have 3. 3 gets plugged in there. Okay? Now, this is the point we know. How does that relate to the original function? Well, we know the points are flipped. So this is the y value of the original function. Okay, well, let's find the y value of the original function. 3 equals square root x plus 5. Square both sides. 9 equals x plus 5. So x equals 4. So when x equals 4, your y is 3. So that fills out that point right there. Okay. And now, because we know the x of the original function, we can find the derivative at that x value. And find the derivative at that x value. So we'll take the derivative, f prime of x equals 1 over 2 square root x plus 5. And we'll plug in our x value. Now notice we're not plugging in a. A just told us our starting point. To be able to get here, get to what we want, we need to find the derivative of the original, and then we'll do the reciprocal of it. So we'll plug in 4, 1 over 2 square root 4 plus 5. 4 plus 5 is 9, square root of 9 is 3, 3 times 2 is 6, so we get 1 over 6. So our derivative at 4 is 1 over 6. Now, these points are corresponding, which means these derivatives should be corresponding, so they're going to just be the reciprocal. So our inverse derivative at 3 is going to equal 6 here. Now, the big way you'll tend to see these problems, though, is something like this, where it gives you a bunch of values, and it says f and g are inverses. Okay? F and g are inverses. That's what it's telling us. So let's start with this first one. We want to find f prime of 4. So we'll say this is f of x, and this is g of x, which is the inverse. Okay? Here's our points. Here's our derivative. Okay? So, or I don't want to write f prime of x, I just want to write derivative. Alright, we want f prime of 4. So f prime of 4. That's on our f side, it's the derivative, we want that. So that's the x value of our f function, which, since these are inverses, would be the y value of our g function. Alright, well, we can look and see where does g have a y value of 4, or where does f have an x value of 4? What information do we have here? Well, we see here that f has an x value of 4 and the y is 7. Okay, so that fills in that point there. And now that tells us what derivative of g we're trying to find. We're trying to find g prime of 7. And so we can look and see, and we see, oh, g prime of 7 is 2, and the reciprocal would be 1/2. So there's our derivative. You can try the same thing on number 5 on your own. That's it. Let me know if you have any questions, and I'll see you next time.